we're going to try and sketch this thing. Now, this looks very different than the last parabola you sketched. The last one looked something like this. It had an x, it had an x squared, it had a number without a letter at all. This thing here has the number with nothing attached, but all this x stuff has been packaged up in a little box. So this form then, if we're going to talk about the shape of the equation, this is called standard form. And it told you about the line the parabola was resting on. So you would sketch your slanted line and then add these x squared values to it. This form is vertex form. It doesn't tell you the line the parabola is built on. It tells you the location of the vertex. And from that vertex, you can count the pattern to generate your parabola. So this thing here, this will tell you the location of the vertex. Tells you the location of the vertex. Okay. Now, if I'm counting the pattern from the vertex, I need to have the pattern. So just remind yourself that your x squared values, 0 squared would be 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, etc. So how does this tell me where I could find my vertex? Well, the x value of the vertex is at, or is when, this thing here, the argument of the square, and that, don't worry about that word too much. It's the stuff that's inside. It's when that equals 0. Now, if you want to think about it for a minute, and don't fixate on this, it's just for your information. When you square something, you always get a positive number. So this thing is always positive, which means this graph is always going to be more than whatever this number is in the back, right? This tells you to start at -10 and put a positive thing on there from there. So if you think about that, that's going to be the lowest place this can go. And if we're talking about a vertex, the vertex is the lowest place you can go. The smallest amount that you can add to that thing, right? I'm not going up at all. I would have to be adding 0 from this function part. So that's why the x value happens when the argument is 0. That's not maybe helpful. If I add 4 to both sides, I get x equals 4, and there's my actual coordinate of the vertex. So I'm going to find x equals 4, 1, 2, 3, 4 on my grid. I'm just going to draw a dashed line like so. So the vertex is somewhere on that line. The y value is the number at the back. So in this case, the y value is -10. So I'm going to draw myself a dashed line at -10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So I'm going to sketch this thing now that I know where the vertex is. I look up at my x squared values. So at this place, I read this equation and said that's where the vertex is. If I take one step to the right, I have to go up 1. Similarly, if I take one step to the left, I have to go up 1. If I take 2 steps to the right, 1, 2, I need to go up 4. 1, 2, 3, 4. Because 2 squared is 4. Other direction, 2 steps to the left, 4 steps up. 1, 2, 3, 4. Notice I'm getting these nice symmetrical pairs. 3 steps to the right, I go to my next x squared value. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Because 3 times 3 is 9. Same thing the other way. 1, 2, 3. Negative 3 times negative 3 is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Next square value up would be 16, because 4 times 4 is 16. So from this vertex, 1, 2, 3, 4 steps over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 steps up. So I end up with this nice parabolic shape. Okay, so in summary, I was handed this equation in this form, where there's some stuff wrapped in a square with a number minding itself at the back. That is the y value of your vertex every time. When this is 0, you'll find the x value of the vertex. So between those two things, you can find where to park that vertex, and then you just count the x squared numbers from there. So got another example there. This is another parabola written in vertex form. I can tell it's vertex form because I have an x minus something all wrapped in a square together. Now from the last example, we talked about how this thing is telling you the location of the vertex. The x value happens when this stuff inside equals 0. So in this example, it's when x minus 8 is 0. Kick that 8 over there. My vertex happens when x is 8. So I'm going to count to 8 on the x-axis. 1, 2, 3, 4, 5, 6, 7, 8, and dash in the yellow line. That will be my axis of symmetry, or the center of the parabola, right? The thing that it's the same on the left as and the right. The y value is the number at the back. So there it is. That number at the back is -4 for this particular example. So I'm going to find where y equals -4. 1, 2, 3, 4. And that's going to serve as my count line for these x squared values. So start going through the list. Find where the vertex is. Take one step to the right, you go up 1. Take one step to the left, you go up 1. 2 steps to the right, you're up 4. 2 steps to the left, you're up 4. 3 steps to the right, you're up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 steps to the left, 1, 2, 3, you're up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Where am I getting these numbers? 0, 1, 4, 9. Those are the perfect squares. You don't have to memorize them. You just have to be able to do 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is 2. 3 times 3 is 9, etc. as you go. 4 steps out, 1, 2, 3, 4. Even if I don't have that list up there, I know that 4 times 4 is 16, so I need to go up 1, 2, 3, 4, 5, 6, 7, 8, 11, 12, 13, 14, 15, 16 squares. And 1, 2, 3, 4 to the left, same thing. 4 times 4 is 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And I can draw in this beautiful parabolic curve. It's pretty good. It's a little hard to draw nice curves when your arm is stretched out like that, but I think that one went well. Okay, so if you can set this thing to 0, like so, and you can read the number at the back, like so, then you can find the location of the vertex. And once you have that, it's just a matter of counting this pattern of squared numbers. We're going to clear this off. We'll try one that has a negative, and then we'll try one with a number in front and see how that goes. Another example of a parabola in vertex form. Again, I can tell it's in vertex form because I have an x plus or minus a number inside of a square. So, and I apologize for repeating myself, I am just trying to hammer this point home. In this form, you have been told where the vertex is. The x value will happen when this argument here equals 0. So when x minus 5 equals 0. Kick this over. The location of my vertex in the x direction is when x equals 5. So find that on your grid. 1, 2, 3, 4, 5, and dash in a line. The y value of your vertex is going to be the number at the back. So there it is. Y is plus 8 in this example. So I find 8. 1, 2, 3, 4, 5, 6, 7, 8. Draw my dashed line across. And that's where the vertex is going to be. Now, in this one, I have a negative in front. So instead of working on the x squared values, I'll be working on the negative x squared values, which would be negative 0, negative 1, negative 4, negative 9, negative 16, etc. I just took these numbers and made them negative. So 0 steps out from my vertex, I drop 0. 1 step out from my vertex, I drop 1. Doesn't matter if I go left or right. 2 steps out, 1, 2, I need to drop 4. 1, 2, 3, 4. Same on the other side, over 2, down 4. If I take 3 steps, 1, 2, 3, my next perfect square would be negative 9, negative 1, 2, 4, 5, 6, 7, 8, 9. Same if you go 3 to the left. 4 to the right, 1, 2, 3, 4. 4 times 4 is 16, and I'm dropping because of the negative. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then the same on the other side. And I end up with this lovely parabolic shape. So hopefully at this point you've sort of pieced together that all we're doing is reading the location of the vertex from this equation and then mapping the same pattern onto it every time, over and over and over again. Because that's really all we're doing. Find the vertex and then add those numbers to it. Oh, another example. I have another parabola in vertex form. I can tell because I have an x plus or minus a number packed inside this square. Now this one is a little different because it has a number out in front, so we're going to have to deal with that. But the primary purpose of vertex form was to tell you the location of the vertex. So we're going to do that first. The x value of the vertex happens when this thing in here is equal to 0. So boot this to the other side with subtraction. The vertex of this particular parabola will happen when x is negative 4. So 1, 2, 3, 4. Draw myself in axis of symmetry there. The y value of your vertex is the number at the back. So there it is, negative 6. So find negative 6. 1, 2, 3, 4, 5, 6. Dash it across. So my vertex is going to be right there. Now, normally, you would be adding an x squared pattern to it. But this one has a number sticking out front. So instead of moving up by the squared patterns, you're going to have to move up by half the square patterns. So half of these numbers would be half of 0 is 0, half of 1 is 0.5, half of 4 is 2, half of 9 is 4.5, half of 16 is 8, etc. So I find my vertex. If I go 0 steps away from it, I should be moving 0 steps off of it. So that's where I start. 1 step over used to be 1 step up. But because we're only taking half this time, it's sort of a half-powered parabola, when I take 1 step, I only get to go up 0.5. Same in the other direction. Take 2 steps. I should be up 2. Take 3 steps. I should be up 4.5. 5. Take 4 steps. I should be up 8. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. Take 5 steps. Now I don't have the number here, but if you think it out, take 5 steps and square it. 5 squared would be 25. But this is a half-power parabola, so I only get to go up half of that. Half of 25 would be 12.5. So 5 steps out, 1, 2, 3, 4, 5, I should be up 12.5. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and a half. Now I can abuse symmetry here, right? The number pattern I had on this side will have to match the number pattern on that side. So half, then 2, then 4.5, then 8, 2, 3, 4, 5, 6, 7, 8, and then I think 12.5 was the next number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There I have my lovely half-powered parabola shifted to the left and down. Wow. This is a high-tech machine, folks. What were we talking about? A lovely half-powered parabola whose vertex has been shifted 4 to the left and 6 down. We have our last example here. It is still a parabola in vertex form. I can tell because I have an x plus or minus a number sitting inside that square. And the point of vertex form is to tell you the location of the vertex. And the x value of the vertex happens when this stuff in here zeroes out. So when x plus 6 zeroes out. Subtract 6 from both sides, I end up with that. So the x-coordinate of my vertex will be at -6. 2, 3, 4, 5, 6. Dash that in. The y value is that number at the back, so it's 10 for this one. So I find 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, draw a dashed line there. My vertex will be here. Now that that's established, I can look at this number in front. So I see a negative, which means it's going to be dropping from the vertex instead of rising. So I can handle that. And I have a 2 out here now, which means I'm not counting the x squared patterns, I'm counting twice the x squared patterns. This is a double powered parabola. So if I take -2 and I multiply it by my x squareds, because -2, there's my x squareds. -2 times 0 is still 0. -2 times 1 is -2. 2 and 4 would be -8. 2 and 9 would be -18. 2 and 16 would be -32, and I'm going to be off the grid, so I can stop writing those out. So, from my vertex, one step, down 2. Another step, down 8 from my count line. 1, 2, 3, 4, 5, 6, 7, 8. Another step, down 18 from my count line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I'm going to squeak through there. Now, go the other way. Start on the vertex. One step over, you go down 2 from your count line. Another step over, you go down 8 from your count line. 1, 2, 3, 4, 5, 6, 7, 8. Another step over, drop 18 from this count line that goes through the vertex. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Nice and symmetrical with that one on the other side. Once you have all these dots on there, just like every example before, you connect them up. And there you go. So, given a parabola in vertex form, you use this chunk to find the x value of the vertex. You use this number at the back to find the y value of the vertex. You look at this number in front and decide if you're using the basic squared number pattern, or if you have to double it, or triple it, or make it negative, cut it in half, divide it by 4. Whatever this number in front tells you to do, you do that to your sequence, and then you just count it from this line, horizontal line passing through the vertex.